All right, so this video is over adding and subtracting radicals. Okay, the first thing you want to do is you want to simplify all radicals. The second step is identify radicals with the same index, meaning they have to both be square roots, cubic roots, fourth roots, so on and so forth, and the same radicand. So what is underneath the radical has to be the same, and only these can be combined. So you want to make sure that they have like terms. Okay, think about when a term has a variable, how they have to have the same variable to combine them together. This is the same thing. So it says for common radicals, add or subtract the coefficients and keep the common radical. So on number 1, you want to start off by simplifying down your radical. So what's the largest perfect square that goes into 27 evenly is 9. So that 3 we just pull down. So 3 times the square root of 9, and 9 times 3 is 27. The square root of 9 is 3. 3 times 3 is 9. So we have 9 square root of 3 is what this 3 square root of 27 simplifies down to. Okay, then we do the same thing over here. So we have that 2 square root of 12, can't do that. So the largest perfect square that goes into 12 evenly is 4, and 4 times 3. The square root of 4 is 2. 2 times 2 is 4. So we have 4 square root of 3. Okay, now because these have the same index and same radical here, we can subtract 9 minus 4, which is 5, and that square root of 3 we just carry over. So 5 square root of 3 is going to be our answer. Okay, number 2. This one right here is all the way simplified down, cubic root of 2. That's what we want to try to get these down to. So what's the largest perfect cube that goes into 54 evenly is 27. So we have the cubic root of 27, which is 27 times 2 is 54, cubic root of 2. The cubic root of 27 is 3. So we're doing 3 times 3, cubic root of 2. Well, 3 times 3 is 9, so it's 9 cubic root of 2. We do not need to simplify this, so we're just going to bring that down. Okay. The largest perfect cube that goes into negative 16 evenly is negative 8. So it's 7 times the cubic root of negative 8, and negative 8 times 2 is negative 16. The cubic root of negative 8 is negative 2, so it's 7 times negative 2. 7 times negative 2 is negative 14. Cubic root of 2. Because these all have the cubic roots of 2, we can combine those all together. So 9 minus 2 is 7. 7 minus 14 is negative 7, cubic root of 2. That's our answer. Okay, number 3. Notice how this has the fourth roots and that has the cubic root. We cannot combine the fourth root and the cubic root. You still want to simplify them all down as much as you can, but you cannot combine those together. Okay, so what's the largest perfect perfect fourth that goes into 48 evenly is 16. That's 16 times 3. So it's 7, and then the fourth root of 16, and the fourth root of 3. The fourth root of 16 is 2, so that's 7 times 2. 7 times 2 is 14, so we have 14 fourth root of 3. This we do not simplify because it's already simplified, so minus 2 fourth root of 3. What's the largest perfect cube that goes into 72 evenly is 8. So that is 3 times the cubic root of 8, cubic root of 9, because 8 times 9 is 72. The cubic root of 8 is 2, so it's 3 times 2, cubic root of 9. 3 times 2 is 6, so we have 6 cubic root of 9. Okay, now to simplify this, what can we combine together? We can combine these two together, so it's 14 minus 2. So we have 12 fourth root of 3, And then this part, because we can't combine it with that, we just pull it down. So plus 6 cubic root of 9. And that is our answer. Okay, number 4. So notice these have square roots that has a cubic root. We still want to simplify them all down, but you cannot combine these two with this. Okay, the largest perfect square that goes into 28 evenly is 4. So it's 10, 4, 7. 4 times 7 is 28. The square root of 4 is 2. Okay, I'm just going to skip a step here, and we're going to multiply that 10 times that 2. So let's go ahead and do that. So 10 times 2 is 20, square root of 7. Okay, cubic root of negative 56. The largest perfect cube that goes into negative 56 evenly is negative 8. So that's cubic root of negative 8, cubic root of 7, because negative 8 times 7 is negative 56. The cubic root of negative 8 is negative 2, cubic root of 7. The largest perfect square that goes into 175 evenly is 25. That's 25 times 7. Okay, square root of 25 is 5, so we have negative 4 times 5 is negative 20, square root of 7. Okay, now, even though this has the same radicands right here as those do, it does not have the same index, so you cannot combine this with these two. But these two can combine together, so 20 minus 20 is 0, so they cancel each other out. So all we're left here with is negative 2 cubic root of 7 is our answer. Okay, number 5, still simplifying down the same way, okay? But another thing with this is when you have variables, they also have to have the same variable to be able to combine together. Okay, this first radical is the only one we need to simplify because that's already simplified right there. So the square root of 98, so the largest perfect square that goes into 98 evenly is 49. 49 times 2 is 98. We can take the square root of x to the 4th and y squared because they both divide by 2. So that goes into the first radical. So the square root of 49 is 7. The square root of x to the 4th is x squared. The square root of y squared is y. Okay, so I'm going to pull this down right here. So to be able to subtract these, this whole thing has to be the same, and they are. So we can do 7 minus 3, which is 4, and then we pull our term down. So x squared y square root of 2. Okay, number 6. The cubic root of negative 40a to the 7th. Well, what's the largest perfect cube that goes into negative 40 evenly is negative 8. And that is negative 8 times 5 is negative 40. 7 does not divide by 3, so we had to break that down to a to the 6th, and that leaves us with an a in the second radical. The cubic root of negative 8a to the 6th is negative 2a squared. Okay. Over here, first, let's simplify the radical part down. That's 2a squared is multiplied times what you get right here. So what's the cubic root of 135? What's the largest perfect cube that goes into 135 evenly is 27, and that's 27 times 5. Okay, so that 2a squared, we're just going to pull it down. Okay, and we said 27, and that is 27 times 5 is 135. Okay, 4 does not divide by 3, so we have to break that down to an a cubed in the first radical, and that leaves us with an a in the second radical. Okay, the cubic root of 27 is 3, and 3 divided by 3 is 1, so that's a. So we have 2a squared times 3a, and that cubic root of 5a just pulls down. So 2a squared times 3a is 6a cubed, And then we still have the cubic root of 5a. Okay, so now, are these the same? Okay, we have an a squared and we have an a cubed there. This part is the same, but those are not, so we cannot combine that together. So this right here is actually your final answer right there. So negative 2a squared cubic root of 5a plus 6a cubed cubic root of 5a. Okay, so that's adding and subtracting. All right, so you have to make sure that they have like terms, so same indexes and same radicands. All right, multiplying radicals. So the first step is you want to multiply the coefficients, then use the product rule. Okay, so what you're doing here is you have to make sure if these are the same index, then you can just combine those together, a times b, so you're just multiplying that underneath the radical. So everything outside of the radical you can multiply together, and everything underneath the radical you can multiply together. So the second step is simplify the resulting radical. Okay, so on 7 right here, they have the same index, so we can multiply these two together. So 27 times 5 is 135. So we have the square root of 135, and then from there we want to simplify. So the largest perfect square that goes into 135 evenly is 9, and that's 9 times 15 is 135. The square root of 9 is 3, so we have 3 square root of 15 is our answer. Okay, on number 8, they have the same index here, so we can multiply these. So we do 3 times negative 2, so what's outside you multiply together, which is negative 6. What's underneath you multiply together, 10 times 18 is 180. Then simplify. Okay, the largest perfect square that goes into 180 evenly is 36. And that's 36 times 5 is 180. The square root of 36 is 6, so we have negative 6 times 6 square root of 5. Negative 6 times 6 is negative 36. Square root of 5 is our answer. Number 9, they have the same index. We can multiply, so 2 times 5 is 10. 9 times negative 24 is negative 216. The cubic root of negative 216 is negative 6, so it's 10 times negative 6, which is negative 60. 10, same index. Negative 3 times negative 1 is a positive 3. 64 times 8 is 512. The largest perfect fourth that goes to 512 evenly is 256. So we have 3, and then 4 times, fourth root of 256, and then we have the fourth root of 2, because 256 times 2 is 512. The fourth root of 256 is 4, so this is 3 times 4, fourth root of 2, so that equals 3 times 4 is 12, so we have 12, fourth root of 2 is our answer. Okay, let's flip over to the other side. Okay, same thing. This time we have some variables in here, so just remember when you are multiplying terms together, you're adding the exponents. Okay, we don't have a number out here, so just treat that as a 1. So 1 times 5 is 5. 6 times 8 is 48. X to the 4th times x to the 5th. You just add 4 plus 5 together, which is x to the 9th. Okay, the largest perfect square that goes into 48 evenly is 16. So we have 5. 16 times 3 is 48. Okay, we're talking about square root. 9 does not divide by 2 evenly. So we have to break that down into x to the 8th and x. The square root of 16x to the 8th is 4x to the 4th. 5 times 4x to the 4th is 20x to the 4th, and we still have the square root of 3x. Okay, cubic root, 54 times 5 is 270. M to the 8th times m to the 4th is m to the 12th. The largest perfect cube that goes into 270 evenly is 27. That's 27 times 10. 12 divides by 3, so we can actually simplify that whole thing. Okay, the cubic root of 27 m to the 12th is 3m to the 4th, and then bring down cubic root of 10. Okay, they're both cubic roots, so we can combine together. Negative 3 times 36 is negative 108. A to the 7th times A to the 6th is A to the 13th. B to the 4th times B to the 2nd is B to the 6th. Okay, the largest perfect cube that goes into negative 108 evenly is negative 27. So you have the cubic root of negative 27 and the cubic root of 4. Because negative 27 times 4 is negative 108. 13 does not divide by 3. So you have to break that down to a number that does divide by 3, which is 12. So you have A to the 12th and A. 6 does divide by 3, so B to the 6th can stay in the first radical. The cubic root of negative 27, A to the 12th, B to the 6th. So the cubic root of negative 27 is negative 3. 12 divided by 3 is 4, so A to the 4th. 6 divided by 3 is 2, so B squared. And then pull down the cubic root of 4A. Okay, 14. 2 times 7 is 14. Fourth roots, we have P squared and P to the 3rd is P to the 5th. Q and Q to the 10th is Q to the 11th. 5 does not divide by 4. So we have P to the 4th and P. 11 does not divide by 4. So we have Q to the 8th. And, whoops, I wrote a G instead of a Q. Q to the 3rd. That 14, we just keep pulling down. Fourth root of P to the 4th is P. Fourth root of Q to the 8th is Q squared. And then we bring down the fourth root of PQ cubed. All right, this next section are binomial examples, okay? We are just distributing here. That's all you're doing. You're still multiplying together, but we need to multiply the square root of 10 times both terms. So the square root of 10 times 5 square root of 5. Well, it's like 1 times 5 is 5, and 10 times 5 is 50. Then we do the same thing here. 1 times negative 2 is negative 2. 10 times 2 is 20. Then you want to simplify. What's the largest perfect square that goes into 50 evenly is 25. 25 times 2 is 50. The square root of 25 is 5. So you have 5 times 5, square root of 2. 5 times 5 is 25, square root of 2. Then we do the same thing up here. The largest perfect square that goes into 20 evenly is 4. So 4 times 5 is 20. Square root of 4 is 2. Negative 2 times 2 is negative 4. We still have our square root of 5. We cannot combine that together because those are different radicals. Okay, that's your answer. All right, here we're going to FOIL. 8 times 3 is 24. 8 times negative square root of 10 is negative 8 square root of 10. Negative square root of 10 times 3 is negative 3 square root of 10. Negative square root of 10 times negative square root of 10 is a positive square root of 100. Okay, simplifying this down. We can combine like terms right here because they both have the square root of 10. So we have 24, negative 8, and negative 3 is negative 11. Right here, the square root of 100 is 10. Now we can still combine these two together. So 24 plus 10 is 34, and we still have minus 11 square root of 10. That's our answer. Okay, this one. 6 square root of 6 times the square root of 6. That is 6 square root of 36. 6 square root of 6 times the square root of 2. 6 square root of 12. Negative 6 square root of 2 times the square root of 6. Negative 6 square root of 12. Negative 6 square root of 2 times the square root of 2. Negative 6 square root of 4. Okay. The square root of 36 is 6. So that's saying 6 times 6 right there. 6 square root of 12 and negative 6 square root of 12. Well, those just are going to cancel each other out. Okay. The square root of 4 is 2. So that's saying 6 times 2. 6 times 6 is 36. 6 times 2 is 12. So we have 36 minus 12, which is 24. Okay. This right here, this whole thing is squared. That means that you are multiplying it out twice. Another way that you can think of this is, remember, you have your perfect square trinomials on your reference sheet. You take the first term and square it, which is 16. Okay. You multiply these two together, which is 4 square root of 5. And then multiply that times 2, which is 8 square root of 5. Then you take the second term here and square it. Well, square root of 5 squared, the square root and the square cancel each other out, and all you are left with is 5. You will get the same exact thing if you FOIL this out. Okay, whichever way is easier for you, you can choose which method you want to do. And then combine like terms here. So 16 plus 5 is 21 minus 8 square root of 5 is our answer. Okay, we want to distribute on this one. So square root of 3k times the square root of 12k. So 3 times 12 is 36. And k times k is k squared. Square root of 3k times negative 2, square root of 15k squared. Well, there's 1 times negative 2 is negative 2. 3 times 15 is 45. K times k squared is k cubed. Okay, then from there we want to simplify. We can take the square root of this whole thing. So the square root of 36 is 6, square root of k squared is k. This one we need to simplify the radical. So what's the largest perfect square that goes into 45 evenly is 9. Can we take the square root of k cubed? No, but we can do k squared. 9 times 5 is 45, and we have a k that's left over right here. The square root of 9k squared is 3k. Negative 2 times 3k is negative 6k. And we cannot combine these two together, even though those are the same. They're not, because this part has the square root of 5k, because this is all one term together right here. So that is your final answer. Okay, on 20, we want to FOIL. So the square root of x times the square root of x is the square root of x squared. The square root of x times the square root of 2 is the square root of 2x. Negative square root of 8 times the square root of x is negative square root of 8x. Negative square root of 8 times the square root of 2 is a negative square root of 16. Okay, the square root of x squared is x. We cannot simplify down the square root of 2x. We'll just pull that down. The square root of 8x, we can break that down because 8 has a 4 and 2. It has a perfect square that goes into it. So we have the square root of 4 and the square root of 2x. 4 times 2x is 8x. Okay, I'll simplify again on the next part. The square root of 16 is 4. Okay, so this next part right here, I'm gonna just pull this down because we've already simplified that. The square root of 4 is 2. Okay, now because these are the same, right here, they both have square root of 2x, we can combine 1 and negative 2 together. So there's nothing to combine with the x, so pull it down. Okay, so 1 minus 2 is a negative 1. Technically, you don't have to write the 1 in front of the radical, so you can just say negative square root of 2x, and then we have minus 4, and that is our answer. Okay, and then the last one right here, it says find the area and perimeter of the rectangle shown to the left. Well, area, you do length times width. So the area, we are doing 4 minus the square root of 6 times 7 square root of 6 plus the square root of 3. And we want to FOIL this. So 4 times 7 square root of 6 is 28 square root of 6. 4 times the square root of 3 is 4 square root of 3. Negative square root of 6 times 7 square root of 6 is negative 7 square root of 36. Negative square root of 6 times the square root of 3 is negative square root of 18. Then we want to simplify, okay? This first part does not simplify. This does not simplify. This one does. So square root of 36 is 6, so it's negative 7 times 6. Square root of 18, the largest perfect square that goes into 18 evenly is 9, and that's 9 times 2. The square root of 9 is 3. Okay, this part right here is negative 42. Those we cannot simplify, so let's just pull them down. There you go. So 28 square root of 6 plus 4 square root of 3 minus 42 minus 3 square root of 2. None of those can be combined together because they are all different radicals. So that is our final answer because that's as simplified as it can get. So that's the area. Then to find the perimeter you do 2 times the length plus 2 times the width. Okay, so 2 times this right here plus 2 times, parentheses, 4 minus square root of 6. Okay, so first we want to distribute the 2's in, so that becomes 14 square root of 6 plus 2 square root of 3. And then over here we have plus 2 times 4 is 8, and 2 times, that becomes negative 2 square root of 6. Okay, we can combine these two together because they both have the square root of 6. So 14 and negative 2 becomes 12 square root of 6. We still have 2 square root of 3, and we still have 8. And those cannot be simplified or combined together, so that is our final answer. That is our perimeter. Okay? All right, so this is adding, subtracting, and multiplying radicals.